Well, hello, third grader, and welcome to another lesson of working with equal groups and to solve problems. And here you see some images. Looks like some little bugs, some insects of different types, rather, and they're in groups, right? What do you notice about the groups? Indeed, groups of 4, as you can see. Rows of 4. Groups of 4. So, if we have equal groups, we know that we can use multiplication or division in that sense, right? And today we're just exploring a little bit more about how multiplication and division are related, right? Just like addition and subtraction are related, so the same can be said for the operations of multiplication and division. And looking at that first row and thinking about the two sentences, 1 times 4 is, one group of 4 is 4, and something divided by 4, sorry, bad time for the autofocus feature to go out on us, but something divided by 4 is equal to 1. Well, in division, we know the total is always going to go first, at least when we're in third grade, and that's going to be 4, right? 4 divided by 4. One way we can think about this sentence is if we have 4, and we do, 4 insects, and we break them into 4 different groups. 1, 2, 3, 4. What's the size of each group? 1. So that's one way we could think about that. You're going to notice as we move on that these types of problems continue. Right? 2 groups of 4. 2 times 4 is 8, and we can see the array. We can see the insects matching. Total divided by 4 equals 2. Well, we've got a total of 8, right? 8 divided by 4. Something times 4 equals 12. Well, how many rows of 4 do we have? Right? 1, 2, 3. 3 rows of 4 equals 12. 12 divided by 4 is equal to, so in this case 12 divided by the size of each group equals the number of groups. Alright? And on we go. So what you're going to notice is that the number of bugs in each particular row form the array that helps us solve each problem. Here we have 4 rows, right, of 4, and we're going to be able to... So if it helps you to move your paper down to be able to see it, well, then do that, and have some fun. Hope these little critters don't bug you too much. All right, on we go. Using these skills with the factors of 4 is really important, and so let's do a couple of these together. First one, a teacher puts 32 students into groups of 4. How many groups does she make? Draw and label a tape diagram to solve it. Well, we can draw the tape right away. Just draw the thing, and right away we know something here, right? We know that the total is always going to go this part of the tape. So let me ask you, do you know the total? When I reread, the teacher puts 32 students into groups of 4, I feel like I do know the total. I think the total of this whole tape, from this side to this side, has got to be 32. What else do we know? Well, reading it again, we know that the groups each have 4 kids in them. So if we take one little segment of the tape, we know the size of that is 4. So we can actually put that in, right? That's the size. That's the number of kids. So what we don't know is how many groups. I'm going to put a question mark here and say groups. All right? Now, just by labeling it like that, I can kind of see what I need to do. And I know that if these groups are each have 4 in them, I can count by 4s. So let's do it. please help me out here. If I make a second group, I have 8. I'm going to label like this. I love that strategy. A third group of 4, 12. A fourth group of 4, 16. 5 groups of 4, 20. 6 groups of 4, 24. 7 groups of 4, 28. 8 groups of 4, 32. Hey, how many kids are there? 32. Do I need this little segment of tape? Nope. I'll just cross it out. Unnecessary. And we've got an answer. We'll just count the little segments of 4, the groups of 4, and we've got an answer. 1, 2, 3, 4, 5, 6, 7, 8. 8 groups, right? That's the unknown, 8 groups. A number sentence that matches this, I believe, perfectly is start with what we know. We know the whole is 32. The total's 32. We can divide by the number of the kids in each group, because we know that, and we find the unknown. Sometimes I like to put a box around it, right? The unknown. 8 groups. And of course, to make this the best answer possible, a statement. How many groups does she make? We can say this quite simply. She makes 8 groups. Statement. Okay? So there's a high quality answer. We'll do one more. We're going to skip over that middle one and do number 4. This one makes our brain think a little bit harder because it's got a little twist in it. An art teacher has 40 paintbrushes. She divides them equally among her 4 students. She finds 8 more brushes and divides these equally among the students as well. How many brushes does each student receive? The reason that it makes me scratch my head a little bit is that there's really 2 parts. And I think I'd like to solve the first part and then solve the second. What do we know? In the first part, do we know the total? I'm thinking you're saying yes. Remember how we just went ahead and drew the tape, labeled the total right away? It tells us this art teacher has 40 paintbrushes. We know that. What else do we know? She divides them equally among her 4 students. Well, I think we know the groups. So we can take this tape and let it show 4, because we know there's 4 students. You use this strategy when you're breaking it into 4. Cut it right in half, then you have 2, and cut the halves in half, and then you end up with 4. It's a pretty good strategy. Anyway, we know there's 4 students, so the missing thing is the size. How many paintbrushes, right? And if you write paintbrushes, question mark, well, that makes sense. You write size, that makes sense. So we have 40, the known total, divided by 4 kids. This is what we're looking for. Now, you may know this, which is cool. If you have this in your head, that's awesome. It might save you the fair share strategy of handing them out. But if you don't know this fact in your head, then you could just hand these brushes out, right? 1, 2, 3, 4, 5, 6, 7, 8, right? It may take you a while, but it's one way to do it, right? I'm at 17, 18, 19, 20. I'm halfway there. Hey, if I'm halfway there, then I can just double these, right? 1, 2, 3, 4, 5. That's an interesting thing. If there's 5 in, and I double that, that makes 10. Let's see if that works. If each one of these is 10, would that work? 10, 20, 30, 40. Hey, it does. So, the answer is, each kid gets 10 paintbrushes. But, are we finished? Because part 2 is she finds 8 more brushes, right? It's almost like another tape. Oh boy, here we go again. 8 brushes. 4 kids. Size is 8 divided by 4 kids. This will be faster, won't it? Let's hand them out. One for you, one for you, one for you. You may know the answer already, right? But I'm just proving it. 7 and 8. Well, they're handed out. How many does each kid get? 2 brushes. Well, in the first part, each kid got 10 brushes. In the second part, each kid got 2 brushes. So, how many does each kid get in total, right? That's what makes this problem a little bit more interesting, right? So, each kid gets, I'm going to go ahead and put this right. 10 plus 2 equals 12 brushes. Okay. And that's how you can, it's one way to solve a problem like this. With a tape diagram that's labeled with a number sentence and with a statement. Well, best wishes to you today. Working with 4s. Working with division and multiplication.